Hey everybody, so in this video we're going to find the upper and lower bounds of a measurement. So we'll work through example 1 and example 2 and then we'll try some exam style questions at the end. If you want to work along with me, I'll leave a link to this PDF in the description below. So for example 1, we've been told that a number has been rounded to 8 to the nearest meter. We need to find the upper and the lower bounds. The way we do this is we draw a number line, and in the middle of our number line we have a number 8. This is 8 meters. Now we're looking at the numbers on either side of this. So below the 8, we've got the 7 to the nearest meter. And then to the other side, we've got 9. This would be 9 meters. So we need to find the point at which a number gets rounded to 8 rather than the 7 or the 9. And this will be the point halfway between the two sets of numbers. So we've got 7.5 here and 8.5 here. So when we're looking between the 7.5 and the 8.5, clearly these numbers are closer to 8 than they are to the 7 or the 9. So we say our lower bound will be the 7.5 meters, and the upper bound would be the 8.5 meters. Okay? For question B, a number has been rounded to the nearest 10 as 40 meters. So again, we draw the number line. This time 40 goes in the middle. And what two numbers do you think go on either side if you're looking at to the nearest 10? Well, it's going to be a 50 and a 30. And we're looking at the numbers halfway between these two. So we're looking at 35 and 45. And then to be rounded to 40, it must be between the 35 and 45. Okay? So our lower bound will be 35 meters, and our upper bound 45 meters. Do you want to try question C? We've got our number line. We have 500 to the nearest 100, so 500 goes in the middle. And then on either side of a 500, we've got the next hundreds, so 600 to the right and 400 to the left. We're looking at the point exactly halfway between the two. So this will be 450 and 550. So the range is between these two. The lower bound will be 450 meters and the upper bound 550 meters. Okay? So for question 2, a number has been rounded to one decimal place as 4.2. We've been asked to find the upper and lower limits as an inequality and as a number line. So we know the lower bound will be halfway between 4.1 and 4.2. So this will be 4.15. And we know the upper bound will be halfway between 4.2 and 4.3. So 4.25. If we let x be any number between the lower and the upper bounds, then x must be less than 4.25. This is writing it as an inequality. Now it can't be equal to 4.25 because if it was, it would be rounded to 4.3. So it has to be less than 4.25. It could, for instance, be 4.24999. This would still be rounded to 4.2. And x must also be greater than or equal to the 4.15. Now it can be equal to the 4.15 because this would still be rounded to 4.2. So this is the upper and lower bound as an inequality. On a number line, Well, we can show the lower bound. We can show the upper bound. Now, because it can be equal to 4.15, we draw a full circle above that number. But because it cannot be equal to 4.25, we draw a hollow circle. And then we draw a straight line connecting the two. So this is how you represent it on a number line. This is how you represent it as an inequality. So do you want to try question 2? So we know the lower bound will be halfway between 0.14 and 0.15. So this will be 0.145. And the upper bound will be halfway between 0.15 and 0.16. So 0.155. As an inequality, if we let x be our numbers between these two limits, it will be less than 0.155, but greater than or equal to 0.145. As a number line, we'll have a hollow circle above 0.155 and a full circle above 0.145. And again, a straight line connecting the two circles. Okay? So this is the basics for the upper and lower bound of rounded numbers. Let's try some exam style questions. So in question 1, we're given the length of a fence is 142 meters, correct to the nearest meter. We've been asked to work out the lower bound and the upper bound. And then for question 2, we've been told that a bag of flour weighs 160 grams to the nearest 5 grams, and Daniel needs 645 grams of flour for a recipe. We've been asked, could 4 bags of flour be enough? So do you want to try these questions yourself? You can pause the video, and when you come back, we'll go through the solutions. Okay, so welcome back. So for question 1, if we draw a quick number line, we've got 142 in the middle. This will be between 143 and 141. Looking at the numbers halfway, the lower bound will be this number, 141.5. And the upper bound, in meters, will be 142.5 meters. Okay, how did you get on? Question 2. So the bag of flour weighs 160 grams to the nearest 5 grams. So if we draw a number line again, 160 is in the middle. Now because we're looking at to the nearest 5 grams, the upper is going to be 165, and we want halfway. So that'd be 162.5. And we're looking at this being the maximum possible weight of a bag. So if it did weigh this much, then the maximum capacity of 4 bags will be 4 times 162.5. This will give us 650 grams. So, could the 4 bags be enough? Well, yes, because you could have 5 grams spare. They will say, yes, 4 bags could be enough, as the upper bound is 650 grams. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and a PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link in the description below.